So assembly language program to sort the given numbers in ascending order or descending order. So the given numbers in an array which need to be sorted in ascending order. So there are numbers from the data memory location 30 to 34. Purposefully those numbers are arranged in descending order from 54 to 11. So our objective is to sort these numbers in ascending order, like 11, 12, 7, 22, 33, 44 would be the same location. That's very important. The same location from 30 to 34. These numbers need to be sorted in ascending order. Okay. So for that we are using the bubble sorting algorithm. So for that we have to go for 4 iteration, and each iteration we have to go for 4 comparisons. So if there are n numbers, n minus 1 comparison and n minus 1 iteration. So in the first iteration we have to go for 4 comparisons. For 4 comparisons we are having 4 columns. How to do the 4 comparisons? The first number and second number need to be compared. After comparing means subtraction. So 55 minus 44, and there is no carry. If there is no carry, the number need to be swapped. So content of the data memory location 30 and 31 need to be swapped. Hence, during the first iteration, first comparison, the numbers are swapped, and we are getting the answer like this: 44 and 55. So 44 is the smallest number when compared with the first 2 locations. Then the smallest number 44 is compared with the next memory location, which is 32 memory location. The current of the 32nd memory location is 33. So 44 and 33 is compared. When it compares, it does subtraction. After subtraction, the 44 is the largest number. There is no carry. If there is no carry, we need to, there is no carry means 33 is the smallest number that is being identified. Hence, we need to swap the 33 and 44 among the 30 and 32nd memory location, as you see here. So 33 and 34 is swapped, as you see here in the screen. And 33 and 44 is done. Then this 33 is compared with 33rd memory location, which is 22. So 33 and 22 need to be compared, and 22 is the smallest number. Hence 22 will come to the 30th memory location, and 33 will come to the 33rd memory location, as you see here. And finally, the fourth comparison with the last number, 22 and 11 need to be compared, and 11 is the smallest number, and 11 is compared with 22, and 11 is the smallest number. 11 will come to the first location. So among the 5 numbers, by doing 4 comparisons, we have identified the smallest number in a particular array. This is very interesting, right? Finding the smallest number in a particular array means this alone is sufficient, right? Among 5 numbers, 11 is the smallest number in this array, which is available in data memory location 30 at the end of the first iteration as subset. Okay. So if our program or if our objective, if our application is finding the smallest number, means 1 iteration is more than enough. So by doing 1 iteration, if there are 5 numbers, if we go for 4 comparisons, we can identify the smallest number. If there are 26 numbers, when we go for 25 comparisons, we can identify the smallest number, and then we can inform the user this is the smallest number. Similarly, largest number. But now our interest is to sort the numbers in ascending order. Hence, we have to go for further 3 iterations, right? So 11 is the smallest number. We don't want to worry about the 30th memory location now. So 31, 32, 33, 34, these 4 memory locations need to be compared. So 3 comparison is enough now. Okay, that's what. Look at the screen. The second iteration, 3 comparison is more than enough. Already 11 is the smallest number which is available in 30. Our interest is to compare the 31 and 32. So when we compare 31 and 32, 32nd memory location is the smallest number, which is 44. So 44 and 55 need to be swapped, and it is swapped. Then in the second iteration, the second comparison, 44 is compared with 33. So 44 minus 33 need to be done, and 44 is the largest number, hence it has to be swapped. So 44 and 33 will be swapped, as you see here. And in the second iteration, third comparison, 33 is compared with 22. So 22 is the smallest number. So 22 and 33 is swapped, as you see here. So at the end of the second iteration, we have identified 22 is the smallest number in the array of 4 elements. So 22 is available in the 31st memory location. So 11 and 22 are the sorted at the end of the second iteration as observed. Now the starting is started for the first 2 elements. At the end of the second iteration, second number was sorted. Okay. Now the remaining numbers are other 3 locations, you have to go for 2 comparisons. The third iteration, you have to go for 2 comparisons. Yes, there are only 2 columns for 2 comparisons. Already 11 is sorted and 22 is sorted. And the number to be compared is 32nd location and 33rd location, which is 55 and 44. So when we compare this 55 and 44, 44 is the smallest number. The 44 and 55 must be swapped. Yes, 44 and 55 is swapped. And you are comparing the second number. So 44 is compared with 33. So 44 when compared with 33, 33 and 44 must be swapped because 33 is the smallest number when compared to 44. So third iteration is over. At the end of the third iteration, 11, 22, 33 are the 3 numbers which was sorted. And you have to go for the fourth iteration. So only one comparison is necessary in the fourth iteration because already 3 numbers were sorted. The only comparison is 33rd memory location and 34th memory location. Both are compared, means 55 and 44 are compared. 44 is the smallest number. So 44 is swapped with 55. So all the numbers are sorted. So at the end of the fourth iteration, 11, 22, 33, 44, 55 are sorted. At the end of the fourth iteration as observed, and the program is over. So the given number, as you see in the top, the given numbers in the data memory location 30 to 34 are 55, 44, 33, 22, 11. And at the end of the fourth iteration, the given numbers were sorted in the ascending order as 11, 22, 33, 44, 55. Fantastic, right? So this is how we have to sort the numbers in ascending order using bubble sorting. So you can write the program using assembly language, C language, C++ language, Python, or whatever it is. Our interest is to write an assembly language program, that too assembly language program using 8051 microcontroller. Let us do the assembly language program for sorting the numbers in ascending order, as you see here. Okay, so the sorted numbers in ascending order is this 11, 22, 33, 44, 55. So quickly to refresh, so 55, how do we do this comparison? First iteration, first comparison, second comparison, third comparison, fourth comparison, that's all. Second iteration, first comparison, second comparison, third comparison, fourth comparison. Third iteration, first comparison, second comparison. And finally, you have sorted the numbers as 11, 22, 33, 44, and 55. Okay, things are happening in microseconds. So quickly the sorting will happen just like that. Okay, to write an assembly language program, we have to begin with org0000h. And we need a lot of pointers, right? We need a lot of pointers where you can understand the registers are very much useful for pointing the starting address first. Starting address is 30th memory location, you can say. So R0 is a pointer 1, which is pointing the starting address of the array. So hence move R0 comma hash 30h, that means move immediately the 30 to the register R0, which points the starting address of the array. Then we are moving the second memory location because the 2 memory locations need to be compared. So the second memory location must be loaded with the next second address, which is 31. So which is moved to the register R1, which is acting as a second pointer. Okay. Then we are using the register R2 to remember number of comparisons, right? Inner loop counter means this R2 is used for n minus 1 comparisons, right? N minus 1 comparisons means n, the number of array is 5 elements. So 4 comparisons are necessary. So to remember the 4 comparisons, register R2 is used. And similarly, register R3 is used for 4 iteration, right? Move R3 comma hash 4. So the outer loop. So there should be 4 iterations. Okay, in each iteration, we have to go for 4 comparisons. Okay. So to remember the number of iterations, R3 register is used. To remember the number of comparisons, R2 registers are used. And to compare which 2 data memory locations, for that R0 and R1 will behave as a pointers. So 4 registers are used as a pointers as well as counters to meet our application requirement, which is sorting the number. Okay. So first number to be compared will be copied from the data memory location 30. That means through this instruction MOVA comma at R0. So this is another indirect addressing, which is interesting, right? So move the content of the memory location pointed by R0 to the accumulator. R0 is pointing 30th memory location. Content of the 30th memory location will be moved to the accumulator. Now very interesting. First number to be compared has reached the accumulator. Second number to be compared must reach the B register. You see, MOV B comma at R1. Second number to be compared is reaching B register from the data memory location pointed by R1. Okay, so move B comma at R1 means what? Move the content of the memory location pointed by R1 to the register B. R1 is pointing 31 memory location. Current of the memory location 31 is reaching B. So two numbers have arrived at the registers A and B. Then it's time for us to compare the content of the register A and B. This is the third type of understanding, right? So this is new way of comparing register A and B now. Okay, so far we have compared with the immediate constants. Today we are comparing with the current of the register A and B. Okay, so compare the current of the register A with B. If the current of the A and B is not equal, then we have to jump to loop. Okay, simply we have to jump to the loop. Okay, so if not equal means we are jumping to the loop and we are checking for carry. Checking for carry means what? If there is a carry, then we can say it is already the smallest number. We can leave it. Okay, if there is no carry means we have to swap. Let us see how they are swapping now. Okay, jump no carry means loop 1. So if there is no carry, it is jumping to loop 1. In this loop 1, we are swapping. Let us see how we are swapping. Content of B register is moved to the memory location pointed by R0. Okay, so that means content of 31st memory location is moved to 30th memory location, because the content of 31st memory location is in B, which is moved to the 30th memory location because R0 is pointing 30. So move at R0 comma B means the content of the register B is moved to the memory location pointed by R0. R0 is pointing 30. So B register content will be moved to the 30th memory location. And similarly, A register content must be moved to the 31st memory location, which is pointed by R1. So move at R1 comma A. So this is very interesting. So this loop one is to swap the memory locations. So R0 and R1 content memory locations are swapped because there is no carry. There is no carry means it is already in descending order. So we have to swap means it will convert into descending order. Hope you understand. So you are doing the comparison. After comparison, if it is not equal, you are coming to loop. In this loop, if there is no carry, we have to swap. Swapping can be done just like that, and then we are jumping to loop 2. Okay. So what is loop 2? Increment R1. That means R0 is okay because R0 is the first memory location which is there. We are going for the second comparison. For the second comparison means internal loop R1 is getting incremented, and decrement jump not 0 R2. R2 is 4. Now R2 will become 3. The first comparison is over. We have to go for the second comparison, and because R2 will be 3, so because it is not 0, it has to go to count. So what is count here? Again, bringing the content of R0, that means R0 that is 30th memory location. Then R1 will be in 32nd memory location. You can see because you have incremented R1. So 30 is compared with 32. Like this, it goes on. This iteration will repeat it. This comparison will repeat it 4 times. Once done means we have to decrement the outer loop. Okay. So second iteration, we have to go for second iteration. The second iteration, we should not go for 4 comparisons. 3 comparison is enough. So once if it is not 0, we have to come to the outer loop. Here in the outer means we are incrementing R0 because R0 content is 30. 30 is being sorted in the first iteration itself, right? First iteration is over. So 30th memory location is the smallest memory location, smallest number. So we have to go to 31. So 31, 32, 33, 34 need to be compared. So R0 is incremented. Similarly, R1 need to be incremented. So R0 to A, then A to R1, something like that. So after that, you are incrementing R1 means R0 will become 31. R1 will become 32. So 31 and 32 will be compared, and the number of comparisons should also be reduced. Now R3 is 3. The 3 will move to the accumulator, and the 3 has to go to R2 for doing 3 comparisons instead of 4 comparisons. Once done, we have to go for stop count, and second iteration will continue from this count, and like this it goes on. When we see an example, it will be very interesting, right? let us do it, let us simulate it in the KEIL IDE, right? Let us simulate the 8015 assembly language program to solve the given numbers in ascending order using KEIL IDE. Let us see how best it works. I am compiling building, debug start. Same code is being written here. R0 30, R1 31, 4, R2 is 4 and R3 is 4. Using this. So this is the program that what we have studied. Let us simulate it, and while simulating I can explain it something better. Okay. Here you can see we can use the same example like 55. We can write it in descending order, right? 55, 44, 33, 22 and 11. 22 and 11, right? Now move R0 with 30, right? So R0 will be loaded with 30. By doing the first execution, R0 is loaded with 30. R1 is loaded with 31. Yes, R1 is loaded with 31. And R2 is loaded with 4. R2 is 0. Single step. R2 is 4. R3 is also 4. Number of iteration is 4. In each iteration, number of comparisons is 4. And move the content of the memory location pointed by R0 to accumulator. So R0 is pointing 30. Content of the data memory location 30 is 55. That 55 will reach the accumulator when we do the single step execution. As 55 has reached the accumulator. Then move the content of the memory location pointed by R1 to B. Content of the memory location pointed by R1. R1 is pointing 31. In the data memory location 31 we have 44. That 44 should come to B after executing this instruction. As you see here, 44 has become B. Now our interest is to compare the content of the register A and B. So A contains 55, B contains 44. So 55 minus 44, definitely it is not equal. So it will jump to loop. So yes, program execution and jump to loop. You can see program counter is pointing this loop. Here if no carry, it has to jump to loop 1. So 55 minus 44, definitely there is no carry, you can see. There is no carry. So we have to jump to loop 1. In the loop 1, what we are doing? Content of the register B is moved to the data memory location pointed by R0. Content of register B is 44. 44 is moved to the memory location pointed by R0. R0 is pointing 30. So content of B register is 44. So 44 will be moved to 30th memory location. So in 30th memory location it is 55. After executing this instruction, 30th memory location will be reloaded with 44. Let me do the single step. Yes, executed. 30th memory location has become 44. Now we are moving the content of the register A, which is 55, to the memory location pointed by R1. R1 is pointing 31. So 31 contains 44, but the accumulator contains 55. So 55 will be overloaded with this 44 after executing this instruction. So single step, 44 and 55. The first iteration, in the first comparison, the numbers are sorted in ascending order. So 44 is the smallest number which has reached the 30th memory location. First comparison is over. Now what happens? Let us do the single step execution now. So where the execution point is, after swapping, you are incrementing R1. So R1 should point to the next memory location, which is 32. R1 is pointing 30 and 32 need to be compared. And the inner loop has to be decremented. So R2 is the inner loop. So 4 minus 3. So because it is not 0, yes, because it is not 0, the program execution has come to the count. So accumulator should be loaded with the 30th memory location. 30th memory location is 44. So accumulator will get 44. Yes, 44. Now memory location pointed a R1 to B. R1 is pointing 32. 32 is 33. So 33 will come to B after executing. Yes, 33 has come to B. Then comparing A and B. A is larger than B, so no carry flag will set. Not equal first, not equal. Hence it is coming to loop. There is no carry. So it will jump to loop 1 to swap. It will jump to loop 1 to swap. So as we did now normally, right? B2 pointed by R0. This is swapping instruction. These two instructions will swap the content of the corresponding memory locations. Now, this 33 will be swapped with this 44. So 44 and 33 will be swapped after executing this. You can see current of B register is moved to the memory location pointed by R0. B is 33. 33 will go to 30th memory location. Now 30th memory location is 44. Single step. 33 will be moved to 30th memory location. Now content of A is 44. 44 will go to memory location pointed by R1. R1 is pointing 32. In 32, we will get 44. 33 and 44. Now it is incrementing the pointer as R1 is 33. R1 is incrementing, which is 33. So R2 is decremented to, because it is not 0, it is going for another comparison. Okay, this process repeats, right? Then you can see 33 and 22 will get swapped, right? 33 and 22 will get swapped. You can see 33 and 22 will get swapped. 22 and 33 was swapped. Okay, let me use this. 33 and 22 will get swapped. Single step. Then 11 and 22 is getting swapped. Then we are going for the first iteration is over, right? 11 has come here. Then we are going for the second iteration. So the 11 is the smallest number among the 5 numbers. So we have to increment the R0 to 32. Yes, you can see R0 will become 31, R1 will become 32. So 31, 32 will get compared and 44 will be swapped with 55, you see. 44 will be swapped with 55. Then 44 and 33 will be compared and 33 and 44 will get swapped. 44 and 33 is compared and 44 and 33 will get swapped. And then 33 and 22 will get compared and 22 and this 33 will get swapped. The same procedure, 22 and 33 will get swapped. Now, at the end of the second iteration is over. First two numbers are sorted in ascending order. And we are going for the third iteration, right? To compare these three numbers. So two comparisons. So 55 and 33 need to be compared. And 33, 44, 55, 33, 44. Third iteration is over, and last iteration, fourth iteration, only one number, 44 and 55. 44 and 53 was swapped, and the program was solved. So earlier it was 55, 44, 33, 22, 11. Now it is 11, 22, 33, 44, and 55. So the given number was in descending order. You have sorted in ascending order. Fantastic, right? To do the same thing in descending order, just by changing this carry, right? So here you can see, here we are using the jump carry, right? Jump no carry, if we change it as jump carry, the sorting number in ascending order will become descending order. That's all. So again, now we are giving it in ascending order, right? 11, 22, 33, 44, 55. Now I am running this. Here I have a breakpoint. It's sorted in descending order, 55, 44, 33, 22, 11. You can see I am sorting it in ascending order, 11, 22, 33, 44, 55. Resetting, running. You can see 55, 44, started in descending order. Fantastic, right? Just by changing jump carry and jump no carry, we can sort very well in ascending order and descending order. But now I'm very much interested in sorting the alphabets. Like this is how our MS Word does. We are very much interested in MS Word now. Here you can see the first loop will fill the alphabets, 26 characters, and we can sort these 26 characters in the ascending order as well as in descending order. This is quite interesting, right? Starting address is 30, 26 characters, what we did in the previous class. So the ASCII character is 41, which is capital A. This loop has to be repeated 26 times to fill the value A to Z. After that, the inner loop is 25. So because there are 26 alphabets, So 25 comparisons, 25 iterations. Okay, in each iteration we are going for 25 comparisons. Then second iteration we go for 24 comparisons. In the third iteration we go for 23 comparisons. That will automatically happen, right? And let us see jump carry and jump no carry, etc. So we are filling the alphabets by using the first program, first set of instructions, and sorting it in ascending order and descending order is happening in the second set of instructions. Let us see this. The same thing, right? Same program, but with alphabets. Let me compile build. Program starts here. This set of instructions will fill the alphabets in the data memory location 30. And this is the program just now we have seen. It starts the number in ascending order and descending order. When you put jump no carry, so jump no carry means it will start it in ascending order. When it is carry means it will start in descending order. See how one bit carry flag helps in completely sorting the numbers in ascending order and descending order. That is the beauty of the flag, right? So you may think that it is a carry flag, but that carry flag is deciding whether to sort the numbers in ascending order or descending order, which is so beautiful and so interesting. Okay, let us see ABCD is coming here or not, like 41, 42, 43, 44, 45, you can see 41, 42, 43, which is ABCD, right? These are all filled continuously. A to Z will get filled, right? So here I keep a breakpoint, and when I run this, it comes up to the breakpoint, and the A to Z will be filled, right? ASCII A to Z was filled, right? A to Z was filled. Now already it is in ascending order, so no problem. So when I'm running and stopping, no change because already it was started in ascending order. Okay, because it is jump no carry. Okay. When I make it as jump carry, here you can very well celebrate this. Okay, I'm making jump no carry to jump carry. I'm running this code, building this, coming back to the debugger window. Now it's time for us to celebrate much better. Now we are expecting 30. So something is going to be filled, right? ABCD need to be filled, right? Let me do the single step, right? F11. I'm pressing F11. You can see A, B, C, D, E, F, G, H, everything is coming, right? K, K, L, M, N, O, P, Q, R, S, T, V, W, X, Y, Z. You can see it will sort it in automatically in descending order. You can see how complexly it is doing, right? Ding, 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 ding. Z will come first. Then Y will come to the 31st memory location. Yes, second iteration is over. Now the third iteration is going on. 25, 24 comparisons. X will come to the 32nd memory location. Now the fourth iteration. W will come to the 33rd memory location. Fifth iteration. V will come to the 34th level location. Sixth iteration. U will come to the 35th memory location. So X, Y, X, Z, Y, X, W, B, U, T, C. See the wonders, right? Same jump carry, jump carry, jump carry, jump carry, jump carry. Rotating, 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 rotating. Keep on doing the 26 iterations. In each iteration, 25. First time 25 comparisons, second iteration 24 comparisons, third iteration 23 comparisons, fourth iteration 24 comparisons, fifth iteration 22 comparisons, sixth iteration 21 comparisons, seventh iteration 20 comparisons. During the 26th iteration, only one comparison. You can see fantastic, right? And finally, see the iterations are going on, going on, going on. And finally, over. Now you can see sorted in descending order A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Earlier it was in ascending order. Now you can see resetting. Now I am stopping a breakpoint here. Now it is in descending order, right? A, B, C, D, A in the bottom. In 49 it is A, the 30 it is Z. So A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, V, W, X, Y, Z. Now when I run this code up to first this breakpoint, it will be refilling with an ascending order, right? Yes, you can see I'm running this code up to this breakpoint. It was done. It was filled with ABCD. In third it is ABCD. When we run this again, it will be ascended in descending order. We did step by step, that's why it took much time. When I run, immediately in 1 second it will happen. So as that is sorted in descending order. Alphabets are sorted in descending order. Alphabets, if you want to sort in ascending order also, you can do just by putting, instead of jump carry, can be replaced by jump no carry, sort it in ascending order. Fantastic, right? So this is how the numbers are sorted in your mark sheets, or you are aligning the folders in the, you are arranging the folders in the ascending order, or you are arranging the folders according to the alphabets in your MS Office, in your Excel sheet, in your PDFs, or in your folders. Everything is only by comparing the numbers behind the screen, because every character is a number, because it is ASCII behind the screen. Those ASCII characters are compared, and then the larger number is kept first, smaller number is kept next if it is descending order, and vice versa in the case of ascending order. Fantastic, right? So compare and jump not equal. Again, here is helping along with the jump no carry and jump carry instruction, helping us to arrange the numbers in ascending order and descending order in the memory location, which is so beautiful. This is how in the hard disk you are arranging everything in ascending order and descending order, arranging according to the alphabets. In your files, we are doing that. In your Word file, we are doing that. In your Excel file, we are doing like that. In your folders, we are doing like that. In your hard disk, you are doing like that. Even in the cloud, you are doing like this. But fundamentally, the principle behind this is compare and jump not equal, and jump no carry as well as jump carry instructions. Fantastic, right? Now I am done. Eagerly waiting for your questions to answer the questions. Fantastic, right? As Sanjay rightly said, understood how to run multiple loops at once. It's very interesting, right? So the inner loop says number of comparisons, outer loop says number of iterations. 4 iterations, 4 comparisons. Sanjay, very good. So Venkateshan says that, okay, sir, for ascending order, it is jump no carry, sir, but for descending order, it has to be jump carry, sir. Just one word, jump no carry and jump carry. வாழ்க்கை தலையில மாத்தி போட்டுருச்சுடா இந்த கேரி அப்படின்னு சொல்ற மாதிரி வெங்கடேஷன். ஜம்ப் நோ கேரினா, இப்போ வாழ்க்கை ரொம்ப கஷ்டமா இருந்துச்சு அப்படின்னா ஜம்ப் நோ கேரி இருந்துச்சுன்னா ஜம்ப் கேரியை மாத்திருக்கேன், வாழ்க்கை இனிமையாயிரும். வெங்கடேஷன், வெரி குட். Then Sudarshan understood how to implement bubble shot algorithm in assembly language. Yes, all of us are familiar with this bubble shot algorithm, but in assembly language, how to do it? That's beautiful. We celebrate it a lot, as Sudarshan rightly said. Fantastic. How to sort the particular array using compare and jump not equal, and jump no carry and jump carry. As Srihari rightly said, compare and jump not equal, a check for equality. Whether it is greater than or less than is identified with the help of jump no carry instruction or jump carry instruction. Fantastic. By using that, we have to do the necessary instructions to finalize whether we are going to do sorting the number in ascending order. It is not only sorting, as we have discussed, right? Finding the smallest number in an array, yes, it can be done. Finding the largest number in an array, it can be done. Who has got the first mark, largest number, that can be identified. Who has got the best mark, that can be identified. Largest number, smallest number, everything can be done, as Srihari rightly said. And our CM is saying, learn how sorting is done and the significance of carry flag. Yes, it is a borrow flag here because it does subtraction. So when we do subtraction, we have to look at the carry flag, but in the name of borrow. Hindu என்ன சொல்றாங்க, carry flag decides whether ascending or descending. Yes, carry flag is saying whether the compared number is positive number or negative number. If it is negative number, that is the smallest number with compared to the reference number. Based on that, you have to write a program in such a way that it can be sorted in ascending order as well as in descending order. Our program decides. Carry flag will never decide whether we have to sort it in ascending order or descending order. By looking at the carry flag, by doing the necessary things in the contents of the registers and the memory locations, we are sorting the program in ascending order and descending order. We are sorting the contents in ascending order, descending order by writing the better way of programming, assembly language programming into. Very nice. Okay, so carry flag is not going to sort the number in ascending order and descending order, but carry flag is used as a tool to sort the numbers in ascending order and descending order. That we have to understand. Very good, Indu.